it's always nice with data if you can show a nice visualization or graphic to help people understand the shape and distribution of your measurement. I'm going to go use that variable childs that we've used before, and this time I'm going to show you how to draw a box plot. Box plots are pretty simple to draw, and the one I'm going to show you here is really not that important a use of the box plot, but I'll show you an example later where you can see that it's most frequently used to compare across different categories, and I'll give you an example in a bit. So here we have our child's variable. You can see it ranges from 0 to 7. I've ordered it because the first thing we need to do is calculate the median. There's 25 cases, an odd number of cases, so we know that there will be a single middle case. It's case number 13, record number 13, and we see that our 50th percentile, or our median, is equal to 2. Now we're going to go ahead and figure out our first quartile and our third quartile. We know to do this, we're going to take this distribution and divide it in half. We'll take the lower half first, cases 1 through 13, and find the median value there. Again, there's an odd number of cases in this subset, so there will be a single middle case. Happens to be case number 7, and so our first quartile is equal to 1. Our third quartile looks at the bottom half of the data set from case 13 through 25, and again there is a single case since there's an odd number of cases. It's case number 19, and our third quartile is equal to 2. So we can go ahead now and start laying out a number line. We can have 0, 1, 2, 3, 4, 5, 6, 7, and 8 children. And when we draw our box plot or our box and whiskers, we know that the box itself extends from the first quartile to the third quartile. So I'm going to draw my box here, and it's going to go to 2. We also know that this box represents the middle 50% of the distribution. Now, there's often a line drawn in the box to indicate where the median is, and the median here happens to be the same as the third quartile. And this is happening because I've only taken 25 cases instead of using the nearly 2,000 cases that we have. But we might do something like change the color of this. So I might draw this in a little bit so that we can see that that's the median. Now we need to draw our whiskers. Our whiskers typically lie 1.5 times the interquartile range. Our interquartile range here is 1. So we know that the lower whisker would extend 1 minus 1.5 and would be up to and including the first case that doesn't exceed that value. So in our example here, our whisker is going to go to 0. We can't have negative numbers, so we can only go there. On the other hand, on the other side of this, we can have 2 plus 1.5, or 3.5, and we know that our whisker then would extend, if we used 4 is greater than 3.5, 3 is less than 3.5, and so our whisker will here go to 3. And then, since I have so few cases, I'm just going to plot out my outliers at 4, 6, and 7. The person who developed this plot has suggested that if points lie 3 times the interquartile range away from your box, they're considered to be extreme outliers. Again, this sample is very small, and so we don't really get all the sense of outliers and so forth. But you can see that this is a nice graphic that shows us the middle 50% of the data right in here, and that it's slightly skewed towards these larger numbers. Here's a box plot or box and whiskers plot I've drawn for the number of children using all of the data in the 2010 General Social Survey, but I've broken it out by religious identity. So as I said earlier, that the box plots are typically best used when you're comparing across categories. So here we're comparing the distribution of number of children by religious identity. You can see that the group that has the most homogeneous distribution are the Jewish respondents. You can see the middle 50% of their distribution covers the difference between 1 and 2 children, has an interquartile range of 1. You can see that the group that has the greatest interquartile range is the Catholic respondents, and their interquartile range goes from 0 to 3, or has a distance of 3 children. You can also see that there are very few, that the whiskers are short for the Jewish respondents and long for the Catholic and Protestant respondents. So again, this is a great graphic to show distributions comparing across categories.